if we just pick up with right where we left off. Okay, so we have, it says, let's make a table and a graph of the function. So f of x is equal to the absolute value of x with the domain from -4 to 4. Okay, so we don't even need to do it in our graphing calculator. Let's just think about this. Okay, so if I'm making a graph. So if I'm going from -4 to 4, say I have the y value of -4, or the x value of -4. So say I have the x value of -4. If I plug -4 into the absolute value of 4, what am I gonna have? Or the absolute value of -4. What does absolute value do? Kaden? Makes it positive. So if I were to plug -4 into that equation, I would have, yeah, +4. So I know I can go ahead and just plot some points. So at -4, I'm gonna be up here at +4. What about if I were to plug -3 in? If I put -3 in that equation, Cooper, what would I have? 3. Braden, what would I have for -2? 2. And then, let's see, Ocean, what would I have for -1? 1. And then, Faith, what about for 0? Yeah, 0. If I plug 0 in, it's not gonna change. So at 0, I'm at 0. And then if I'm gonna plug a +1 in, does the absolute value change anything when you put a positive number in? No. So we know that at 1 we'll be at 1, at 2 we're at 2, 3 we're at 3, and 4 we're at +4. Okay, so I would have this V-looking graph. Okay, so it would be something just like this. So here we have our absolute value of x. With a domain, I go from -4 to +4. And actually, since it doesn't say infinity, I can take my arrows off. So it just goes from -4 to +4. Okay, so now it says let's do the same exact thing, but this time we have the function 2 times the absolute value of x. Okay, so if I take all of these points, if I take -4 and I plug it in right here, so -4, the absolute value of -4 would be what, Haley? 4. And then if I take it times 2, I'd have 8. Okay, so now at -4, instead of being up at +4, I'm gonna be at 8. So I don't need any negatives. So at -4, I'm up here at +8. Okay, Paige, what about if I put -3 in? What would I have for this one?
6.
Yeah, I'm gonna have 6. So -3, I'm gonna be at +6. Okay, what about Jade? Where will I be at -2?
4.
4. Cool. So at 2, I'm at 4. And then at -1, Mackenzie, what would I be at? 2. And then at 0, what do you guys think? 0, not gonna change. And then is the other side just gonna mirror this just like we did before? Yeah, so at 1, I'm at 2. At 2, I'm at 4. At 3, I'm at 6. And at 4, I'm at 8. So here, I have this graph right here. So you can see it's the same exact shape as that one over here, but doesn't this look like the lines are a lot steeper? So it looks like I either like stretched it or compressed it or something happened to it. It's still the basic shape, but now it's just changed a little bit. The lines are just a little steeper. So in terms of stretching and compressing functions vertically, okay? So when the domains of the function are the same, so we went from -4 to +4 on both of them. So when the domains are the same, but the g of x function has been stretched vertically. So here we have our pictures of our graphs that we just drew on the board. So we can see we still go from -4 to +4, but the G, it's been stretched vertically. All the points have just been stretched out. We multiplied them by 2, they got bigger. Okay, so in order for, when you stretch, just the definition, it says a transformation that increases the distance between the points of a graph and a given line by the same factor. So all of our points had to be multiplied by the same number. You couldn't multiply 1 point by 2, 1 point by 4, like, so in order for it to be considered a stretch, every point gets multiplied by the same number. So then whenever you write the equation, so when we're writing equations for transformations, it says write whatever number you're stretching or compressing by. So in our case, we were multiplying by 2, we were stretching by 2. So you would write a 2, and you put that number in front of your original equation. So if I had an example like this, say I have this function right here. So if I have x minus 3 squared. So looking at this right here, if I think about what we talked about with transformations on Thursday, this minus 3, where is that shifting the graph? Am I going up, down, left, right? What do you guys remember? If I'm in the parentheses, does that mean up or down or left or right? Mia, what do you think? Down. Okay, so it is minus, so that's a good, so minus is for down, but because I'm in the parentheses means I'm going left or right. Okay, so I'm going left or right, and then because it's minus with that, do you think it's gonna be to the left, to the negative side, or to the right, to the positive side? Jade, what do you think? To the right, yep, because remember it's opposite. So remember the left and the right is opposite of what you think. So we are actually gonna go over to the right 3. So basically if I had this graph, so say that graph would look something like this. It's a quadratic because I have the squared, and then it's moved over 3 to the right. So it'd be like a little U like this over here. Okay, so that's what that graph's gonna look like. But if it's gonna be stretched by a factor of 7, all I have to do is put that 7 out front of the entire equation. I don't just put it with the x, I put it in front of everything because the entire equation would be multiplied by 7, okay? And sometimes you won't actually be given like an equation, you're just saying, hey, the graph, your f of x, your function, your graph is getting stretched by 7. So you would just put the 7 in front of the f of x. So just means basically, so anytime you're stretching or compressing, all you do is write the number in front of the entire equation. Okay, so that's how we would write those. Everyone okay so far? Yeah. You guys are always so quiet, you freak me out, like, compared to your other classmates in the afternoon, I'm sure you can think of them, look around, see who's not in here. All those boys. Okay, let's talk about horizontal now. All right, so let's do the same thing again. So we have, it says, let's make a table and a graph for our absolute value of x. Okay, we did that already up here. This time it says with a range. So we're not talking about domain, we're talking about range this time. And the range is from 0 to 4. So remember range, you go from bottom to top. So I went from 0 on the bottom up to 4. So we're good, we did that already. So now it says, let's do the same thing, but this time, the 2 is in with our x, it's inside of the absolute value, it's not on the outside. So this is where we'll see the difference. So, I can start over here. So if I have the function, so f of x is equal to the absolute value of 2 times x. So, we'll go ahead, we'll go from -4 to 4. Okay, so if I take -4 and I put it in here, so what I would have to do is I would have to first multiply it by 2 and then take the absolute value of that. So if I take -4 times 2, what does that give me? -8, and then if I take the absolute value of that, 8. So actually I'm gonna end up being up here at 8 again. So at -4, I'm up here at 8. Okay, what about if I plug -3 in? Mackenzie, what do you think for this one? yeah, it's gonna be 6. So negative 3 times 2 gives me negative 6. If I multiply by, or I take the absolute value of that, it's gonna give me 6. What about for negative 2, Faith? What do you think? 4. Ocean, what about negative 1?
2.
At 2. Mia, what do you think for 0?
0.
Cool. And then this other side, gonna be the same? Yeah, we always have the same on the other side. So at 1, 2, 2, 4, 3, 6, and 4, 8. And I don't need arrows. All right, does that look like the same graph that we did last time? In the last example?
Yeah.
So sometimes they are the same and sometimes they're not. So conveniently, this example just showed you that they can be the same, but that's not always the case. So don't always think that like a vertical stretch and a horizontal compression are the same thing. Sometimes they are, sometimes they're not. Okay, so if we look at our examples right here, so when we're talking about the range, because we're talking about horizontal, so the range, it went from 0 to 4, but now the range, it got stretched vertically from 0 up to 8. So we stretched it vertically, but then we also like compressed it horizontally at the same time. So it says the ranges of the functions are the same. Oh, because we went too far. We were only supposed to do the range from 0 to 4, if I go back to that example. So here, sorry. So we're limiting our graph with the range of just 0 to 4. So if I limit both graphs and I only go from 0 to 4, that's gonna take all of this stuff off, okay? So now these two graphs have the same ranges. Do you guys see that? Are you okay with that? Sorry, we just did more points than we needed to. Okay, so this graph goes from 0 to 4, and then this graph also goes from 0 to 4, okay? But you can see that this one's way wider, and then this one's skinnier, okay? Because I can only go from 0 to 4 because I had to limit that range. Okay, so then talking about that. So it says the ranges of the functions are the same. They both go from 0 to 4. But the function's been compressed horizontally. Because if you think horizontal is gonna be like this way. So instead of it being all the way like wide, I made it skinnier. I compressed it horizontally. Like this is skinnier. Because if you look, instead of being at 2, 2, that point's now at 2, 4. Like this one that was at 1, 1. At 1, 1, I'm actually at 1, 2. So like really, the whole graph has been compressed horizontally, okay? So then in terms of compression, that's just when you decrease the distance between the points on a graph by the same factor. And for writing these equations, all you have to do is this time with the number, whatever you're compressing or stretching horizontally by, you put that number just on the x. So it's not on the entire equation, it's just with the x. So like down here on this example, so using that same quadratic example, instead of the 7 being out front of everything, the 7 is just with the x, okay? So the big difference is vertical, you just write the number outside of the entire equation. Horizontal, you write the number just in with x, okay? So that's how you write those equations. And they do, those numbers kind of then change what's going on with the graph.
Matthew Byert, please come to the high school office. Matthew Byert, please come to the high school office.
Okay, so then here's a quick cheat sheet. And I would actually, I know I tell you you don't need to write everything down because I just talked through it. I would write all of this down because for your project, you're gonna be doing every single one of these transformations. And this is just a handy little cheat sheet. And then also, I know this is kind of a ways off, but every test and quiz, you guys get a note card in here. So you can write whatever you want on the note card, formulas, random information. This is just a nice little cheat sheet that probably come test time, I would write it on my note card. Because even sometimes I forget like which way things go, okay? So C is just a constant, so whatever number. So like in our example, we were talking about 7. So if our value of C is greater than 1, it's gonna do these 4 different things, okay? So if you have the number outside of the entire equation, it's gonna stretch the graph vertically by whatever number that is. Okay, so if the number is on the outside of the entire equation, it stretches it vertically by that. If the number is a fraction, so say it's like 1/2 or like 1/4, whatever it is, this is where the compressions come into play when it gets smaller. So I'm just gonna use 7 for all of these. So if I'm gonna stretch the graph vertically by 7, I would put 7 right here. But if I'm gonna compress by 7, then you're gonna have a fraction. So you would have 1/7 outside of your entire function. And now for the horizontal ones, this is where the number is just in with the x. It's not with the entire equation, it's just on the x part. So if you're doing a compression, you're gonna have that number right there. So say you're compressing horizontally by 7, you would put the 7 just with your x. And then if you're stretching the graph horizontally by 7, this, when it says x over c, that would just be like multiplying by like 1/7. It'd be like x over 7, so 1/7, okay? And then when it talks about the negatives, this is the reflecting that we talked about before. But so if your value is negative, that's when we get those reflections. So if you have a negative out front of everything, it reflects it across the x-axis. And if you have a negative just in with your x, this is where it reflects it across the y-axis. Okay, and this is just the handiest little cheat sheet. So if you're looking at an equation, you just look at what that number is, look at where it's at, like, oh, it's out front of the entire equation. Okay, I know it's one of these. Oh, it's a fraction. This is gonna be the case. It's gonna be compressing it vertically, okay? Like I said, I never expect you guys to like memorize stuff in here. I just expect you to know how to use it. So if you're looking at your homework and it says, here's this equation, describe the transformations. Well, if you look at it and you see 1/7 times f of x, you can say, oh, okay, it's outside here, so it's gonna be this case right here. Or, oh, it's a negative, okay, it's gonna be this case right here, okay? So just being able to look at this little chart and see what's going on. So just look at your number. If your number's negative, you know it's gonna be these. If it's positive, it's gonna be one of those. And you can have more than one at the same time. It could be negative and a fraction, so you could be reflecting and compressing it vertically at the same time, okay? So multiple transformations. Cooper, I met your brother this weekend. He was at the school on Friday. I don't know, he was outside and he was like locked out, and I went for a run over my lunch on Friday and I came back and I was locked out because I didn't take my key with me. And so Mrs. Gorder was in her room, so I like knocked on the window and your brother and his friend was like sitting there playing, and they're like, oh yeah, nobody's in the office. And I'm like, oh yeah, no, that's fine. Like, and then he was like, yeah, my dad went to lunch or something. And I was just like, oh, who's your dad? Because I like don't know your brother at all. And I'm like, who's your dad? And he's like, Mr. Schoenberg. I was like, oh, okay. So yeah, so I met your brother. Yeah. How many siblings do you have, Cooper?
2.
Do you have a sister?
Yeah, she's in middle school.
Oh.
8th grade.
Okay, gotcha. Jade, you crack me up every time I look at you. You just remind me of Jesse too much. Jared doesn't look anything like you guys.
No,
Yeah, so when I look at her, I don't see Jesse.
it looks a lot like mom.
Oh, really? No. Okay, guys, so here I have a graph, and we're gonna talk about a combination of functions. So, here's my graph right here. This is just my f of x, okay? So it's not a normal looking graph, it's not absolute value, it's not a quadratic, it's just a graph. So we're just calling it f of x. I don't have like an equation for it. But what I wanna do is I wanna graph negative f of x plus 2, okay? So if I have this x plus 2, that's in my parentheses. So if I'm in parentheses, am I going up or down or left or right?
Left or right?
Left or right. And if it's plus, am I going left or am I going to the right? Yeah, yep, it's always opposite, okay? So plus goes to the left, to the negative side, not to the positive side, okay? So I can go ahead, I'm just gonna plot a couple of these points real quick, and then we'll move the points, we'll transform them, okay? So I have, you can see I have a point at negative 4, 2. So at negative 4, 2, I have a point. I have a point up here at negative 2, 4. And then I have this other point at negative 1, 3. And then the last one, I have one over here at 1, 7. Okay, so these are the points that we're gonna move around. Okay, so here's that graph. Okay, so if I'm shifting that graph, we just said that we're going, so it's plus, so it's going to the negative side. We're going to the left 2. So every single point, I can move it over 2, okay? But then also, what does that negative in front of everything do to it? So we know when we see negatives, we can think about reflecting. And so we either have the option of reflecting over the x-axis or the y-axis. So if it's a negative in front of all of it, what do you guys think? Mackenzie? Yeah, it's gonna be the x-axis, okay? So each of these points, I'm gonna go reflect it over the x-axis and move it left 2, okay? So this point that's at negative 4, 2, if I move it left 2, I'm gonna be at negative 6, 2, and then if I reflect it down here, I would be at negative 6, negative 2. Does everyone see how I got that? So we took this point, we went left 2, and then over our x-axis. Okay? So then, Kaden, this point that's at negative 2, 4, if I go left 2, where am I gonna be at?
Left 2, you're gonna be at negative 4, 4.
Yep, and then if I reflect it,
4, 4.
yeah, so I'm gonna be at negative 4, negative 4. Yeah. So my next point is down here at negative 4, negative 4. Okay? Then this one, Braden, that I'm at negative 1, 3. If I go left,
Negative 3,
negative 3, positive 3, yeah, and then negative 3, negative 3. Yep. So negative 3, negative 3. And then the last point that's at 1, 7. Ocean, if I go left 2, where am I at?
Negative 1. And then down 7, negative 7.
Yeah, negative 1 and then down 7, so we'd be all the way down here. Okay, so then I can connect those points. And you can see, so that's that graph shifted over to, and then it's reflected down here. Okay? Does everyone think they can do something like that? Yeah. Okay, so then here's just a picture, because my graphs are always not awesome. But so we moved it to the left too, and then we reflected it, and that's what we just drew over there.
Hey, Mrs. Merriman, what's
Yes.
for lunch?
I think it's like tacos of some sort. But I don't know, because it's not on my September calendar and it wasn't on my
Yeah,
August
it's not
calendar.
on online either. They're
Yeah.
listing this today.
Yeah, so I think that's, they like emailed us last week and said that they forgot to put it. It's tacos or something like Mexican, so. Okay, let's just identify transformations. So this one, I have g of x is equal to negative 1/3 x squared. Okay, so my original graph would be just x squared, but I can see I have a negative out front of everything, and then I have a 1/3 in with just my x. Okay, so we can list these transformations. So I have two transformations. I'm just gonna do like 2 bullet points. This negative that's out front of everything, what do you think that does to the graph? What do you think, Jade?
Up or down?
What'd you say?
Up or down?
Up or down? So negatives are gonna reflect it. So if we have just a number on the outside, that moves it up or down. But let's see, Mia, do you have a guess? What's the negative gonna do? Across the y-axis. Okay, so I like that we're reflecting, but since the negative is out front of everything and it's not in these parentheses with just the x, what axis should I actually go over? Haley, what do you think? Yeah, it's gonna go over the x-axis. So anytime the negative is out front of everything, it's the x-axis. When the negative is in with just the x, it's the y-axis, okay? So I'm gonna reflect over my x-axis. And then, let's see, so this 1/3 is in with my x. So if you look at that little table cheat sheet I made you guys write down, what's that gonna do? Cooper, what do you think?
Is it the one that says reflects the graph of f across the x-axis?
Yep, so we got that one for the negative. What do you think for the 1/3 though? Braden, help him out.
Vertical compression?
You're thinking of vertical compression?
I'm thinking so.
Is anyone also thinking of vertical compression? Jade's saying no. Jade, what are you saying? I'm gonna say, let's go back to our table. Okay, let's look. So the 1/3 is in with our x. So I know it has to be one of these ones, because these are the ones where the number is in with your x. And then this one where it says x over c, that's the fraction, because that would be like, because 1/3 is the same, x is the same thing as x over 3. Are you guys okay with that? 1/3 x and x over 3 are the same thing, because this would just be like 1x over 3. So, since I have 1/3 x, I know I'm looking at my fraction one. So I would be this case right here. So I'm gonna stretch horizontally by 3, okay? So I have a horizontal stretch by 3, okay? And all of them, even if they're the fractions, you still are stretching or compressing by whatever the C value is. You're not by the not by that fraction, but by the actual number 3, okay? But because it's the 1/3, that means it's the horizontal stretch. Okay, so horizontal stretch by 1/3, or by a factor of 3, sorry, not by 1/3. Okay, let's look at the other one. Okay, so this one I have x minus 4 squared plus 5. Okay, so the plus 5 on the outside, what do we think that's gonna do? Faith, what do you think? Okay, so you're thinking we're gonna move it to the left. Are you talking about the 4 or the 5? The 5. Okay, so left or right is gonna be with our parentheses, and the number on the outside is the up or down, okay? So I know this stuff is super confusing, that's why we're gonna do a project on it, but by that, like how Brady was sitting in here, was Brady in your class on Thursday? Or was he in my other class? But it's something you'll totally get. Like all this will make sense the more we use it, okay? So the plus 5 on the outside means we're going up or down. And because it's plus, should I go up or should I go down? Let's just take a vote. If you think you're going up, raise your hand. Ocean thinks we're going up. Kaden thinks we're going up. Jade thinks we're going up. All right, if you think Cooper thinks, if you think we're going down, raise your hand. Okay. So the up and the down is kind of straightforward, like up goes to the positive, down goes to the negative. So if it's plus, it goes up. If it's minus, it goes down. So only when it's in the parentheses is it opposite. So we're actually gonna be going up 5. Okay, so we're gonna go up 5. Okay, so plus, when it's not in the parentheses, goes to the positive side. It goes up 5. Minus goes down, okay? And then the parentheses is where it's opposite of what you think. So this is -4. So instead of going to the negative side, I go to the right, don't I? So I'm gonna end up going right 4 for this other one. Okay? So our transformations for this graph, I go up 5 because it's plus 5. And then the -4 is gonna take me to the right 4. Okay? Questions about things? Okay, one last example. All right, so we have, it says a scenic train ride makes trips on an old mining line. The graph shows the distance, which is our y, in kilometers, of the train from the station X minutes after the ride begins. So here I am at 0, 0. So as the train starts going, it drives away from the station, and then it's gonna turn around and come back, okay? So as the time keeps progressing, it goes farther away, and then it gets closer, it comes back to that station, okay? So it says, what equation represents the distance from the station as a function of time? And so this right here is our general form of our absolute value equation. So this is exactly what we've been talking about with transformations. So this A out front is gonna be for our stretch or compression, okay? So that A is gonna be the number that you're gonna put out front for if your graph is stretched or compressed. This H is just a placeholder for whatever number you're gonna use if you go left or right. And then the K is for your up or down. Okay, and we will see this over and over. This is the same form we'll use with quadratics, with cubics, with polynomials. Like every type of graph we're gonna learn this year is gonna have these same transformations because all the graphs get transformed the exact same way, okay? So this is for the left or right, the H is for the left or right, the K is for the up or down, and then the A is just for like if you have a negative, if it's reflected, or if it's stretched or compressed. This is just like a placeholder for that constant right there, okay? So we are trying to write an equation of what we see in that picture. Okay, so looking at it, I'm just gonna write this general form. So I have y equals a absolute value of x minus h plus k, okay? So if I look right off the bat, so I have this point right here at 15, 15. So if you think our normal absolute value when we were talking about transformations, that was that V, like this, right? It had its point right here at 0, 0, okay? So this one, instead of having its point at 0, 0, its point is at 15, 15. So this graph right here, do we know that it's all been reflected? Because isn't it upside down? Yep, so it's been reflected. It also hasn't it also been moved up? And then it's also been moved to the right. Because compared to this graph right here at 0, 0, to get to that graph right here, I have to move my point this way and up and then turn it over so that it's now opening down. Okay? So in terms of transformations, I went up 15, I went right 15, and I'm reflected. Okay? So we can go ahead, let's plug in some numbers. So we just said we had to go up 15, didn't we? So would that be plus or would that be minus? What do you guys think?
Plus.
Plus. So I can go ahead and instead of K, because that's just a placeholder, I can put plus 15 right here. Okay. And then because I went to the right 15, is my H gonna be, is it gonna be plus 15 right here? Is it gonna be X plus 15 or X minus 15? Yeah, it's gonna be minus, yep, so X minus 15. And then for this A value right here, it's kind of hard to tell if it's been stretched or compressed, isn't it? Yeah, that's always the hardest thing. So we actually have to solve for that. But don't we know that it's been reflected? And if it's reflected, can I put a minus or a negative sign up here? So I could put negative A. Because I don't know if it's stretched or compressed, so I can't fill in a number for A yet. But I do know it's been reflected, so I do know I need that negative, right? Okay, so now all we have to do is solve this. So I can put any other point on my graph in for my X and my Y, and then I can solve this for my A to figure out if it's stretched or compressed. And I like to do things the easiest way possible. So right here, I'm at 0, 0, right? So I'm gonna put the 0, 0 in for my X and my Y, because those are easy numbers to work with. So if I put 0 is equal to negative A, absolute value of 0 minus 15 plus 15. So now all I'm gonna do is I'm gonna solve this for A. Okay, so if I take 0 minus 15, what do I have?
15.
Yeah, it's gonna be negative 15, but then because of the absolute value, it's positive 15, right? And then this is multiplied, okay? So anytime you have something outside of your absolute value or outside of your parentheses, it's multiplied. So basically I have negative A times 15, and then I still have this plus 15 is equal to 0. So now I'm trying to get A all by itself. So what could I do next? Brayden, what do you think?
Divide both sides by A.
Divide both sides by A. Before I would do that, can I subtract my 15 over to the other side?
Yes.
Yes, let's do that. So we always wanna, anything that's added or subtracted, we always wanna move that to the other side. And then from there, we can deal with the multiplication or division. So I'd have negative 15 is equal to negative A times 15. Now this 15 right here, how can I get rid of it? That's, if I'm multiplied by 15, what's the opposite? How do I? Yeah, divide. So if I have negative 15 divided by 15, what does that give me? Negative 1. So I have negative 1 is equal to negative A. So if I need positive A, what would I have? Yeah, divide by negative 1, so I just have positive 1, right? Okay, so I know now that I solved out my A is just 1, I'm not stretched or compressed. So then if I needed to write my equation, I would just have Y equals, and now instead of negative A, I know it's negative 1. So I'd have negative 1, absolute value of X minus 15 plus 15. And that would be that equation of that graph right there. Okay? And that's everything. I know this was like literally the first couple sections in this book are just a lot, and then it gets better. Like everything else is way shorter, so. But does anyone have questions, concerns? No? Okay, so then yeah, so tomorrow is just the map test. You guys do have homework for section 2, and you actually won't have a work day. because you'll have like a week to do your homework while you also are doing your transformation project. So if you're bored during your flex, you can start that homework on Schoology. And then there is an IXL too, okay? But the homework won't be due for like a week, and I'll talk about that again later, okay?